Today we're going to be learning about systems of equations. Alright, so the first method for solving system of equations that we're going to talk about is substitution. So you are given two equations that look like this, and you're asked to solve them. And what this means is finding a value of x and y that satisfies both equations when plugged in for x and for y, but will work for this one and will work for this one. Alright, both equations will be true. Alright, now with substitution, we're going to take this top equation and we're going to plug it into this one to solve for the value of y. Or of x, I'm sorry, for the value of x. Alright, so since this is a y equals, we're going to plug it into the y part of this bottom one. So we have negative 2x minus 3, and then parentheses, 6x minus 11 equals negative 7. So see how we just kind of took this y equation and plugged it in for the y part, minus 3 in parentheses, because this is where y is here. We put the y in, 6x minus 11. Alright, so we did that. So then you get negative 2x minus 18x plus 33 equals negative 7, negative 20x equals negative 40, x equals 2. So now we have our x value, but we still need our y value. So to find our y value, what we're going to do is we're going to plug in this x value into the first equation. So we're going to go y equals 6 in parentheses 2, because instead of just writing an x, we're going to plug in this value of x, or this value of x, my bad, minus 11. So then it's y equals 12 minus 11, y equals 1. So that was pretty simple. Now we have values of x and y, 2 and 1, that satisfy both equations when plugged in for both x and y into both. Alright, let's do one more with substitution. We have these two equations, y equals negative 3x plus 5, and 5x minus 4y equals negative 3. So we're going to take this top equation, we're going to plug it in for y in this bottom equation, 5x minus 4 in parentheses, because we're substituting this y for this equation, minus 3x plus 5 equals negative 3, 5x plus 12x minus 20 equals negative 3, 5x plus 12x equals 17, 17x equals 17, x equals 1. Alright, so that was really quick, but pretty much I'm just solving this equation. The only part I really need to go through with you guys is this substitution part, which is new. Alright, so then we have our value for x. We take it, we plug it in to this top equation, y equals negative 3 in parentheses, because we're substituting this value of x, or this x for this value. Y equals negative 3 in parentheses 1 plus 5, y equals negative 3 plus 5, y equals 2. So so the values that satisfy both these equations are 1 and 2. Alright, what's cool is that there's another way to solve systems of equations, and it's by graphing. And what you do for that is it's pretty simple. Since I've already taught you guys graphing, it should go by really quick, explanation-wise. But what you do is you graph both of the equations, and the place where they intersect on the graph is the solution, or the two values for x and y that satisfy the equation. So let's just do this really fast. We have y equals negative 5/3 x plus 3. Let's graph that. Go up to 3 for our y-intercept. And it's a negative, so it's going to be going this way on the graph. So rise over run, so it's negative 1, 2, 3, 4, 5. Run 3. Alright, that's our first one. Next is 1/3 x minus 3. Y-intercept is negative 3 down on here on the graph. It's a positive slope. Rise 1 over 3. And look at, they intersect at this point, 4, negative 3. And if we were to do this by substitution, we would also get 4, negative 3. Because this is the value of x, and this is the value of y that satisfy x and y in both of these equations and make both of them true. Alright, let's flip the page here and do one more really quick graphing example. We have y equals 4x plus 3. Let's go up to 3 for our y-intercept. Rise 1, 2, 3, 4 over 1, because 4 over 1 is 4x for our slope. So we rise 4, we run 1, and it's positive because it's a positive 4x, so we go upwards. Next we have y equals negative x minus 2. Go down to minus 2 on our graph for our y-intercept, and negative x is just equal to negative 1, so it's negative 1 over 1. So we go down 1 over 1, and this is our line. And hey, they intersect right here at this point, negative 1, negative 1. And if we were to do this by substitution and put this into this, again, we would get the value of x and for y in this case as negative 1 that satisfies y and x in both of these equations and makes them true. Alright, now I'm going to challenge you guys to solve this one with substitution and with graphing. Hopefully you'll get the same two values, that's one hint, for these two equations. Negative 3x plus 3y equals 4 and negative x plus y equals 3.